applications of text related. Basically, we are seeing lots of applications of text in the context of economics, especially sentiment analysis. So in this last week, which is so there are only 3 lectures left in this class in this semester. So the 3 lectures in this week. So here basically what we will try to do is how we can do the various tasks related to sentiment analysis and so on, which are necessary for text processing in general, not necessarily in the context of economics. So so first of all, let us so basically what we are going to discuss today forms the basis of natural language processing. We will not go into much details, but we will just see some of the ideas of natural language processing and some simple algorithms to using which those ideas can be achieved for some tasks which which will be useful for the kind of problems which Professor Siddhartha Chatterjee and Professor Sudeshna Sarkar had mentioned in the last class. So first of all, let us start with the very basics of any language. Okay, so suppose we are considering any language. So let us consider English as a case study. So we can say in the following way, a language has the following things, has the following components. The first component is of course the vocabulary. What is vocabulary? Vocabulary of any language is of course the set of words. Okay, the set of words. Now if you consider a particular language, from where will we know the entire set of words in that language? So it's rare to have a single source which contains all the words in a particular language. I mean a dictionary will have it, but then again the language also keeps expanding. But now if we are dealing with a particular problem related to natural language processing in general, we may not need the entire set of all words in the language which we are looking for. So what typically happens in a natural language processing problem is that we are provided with a corpus of documents. So what is a document? Document, we all understand what a document is. Now a document need not be a piece of paper in this case, but it simply means that it's a kind of it's an unit of any storage of words or any text data set, you can say. So the so document basically is a collection of words. We can consider any document as a collection of words or as a sequence of sentences or whatever you may want to call it. Now so suppose there is for one particular task of related to natural language processing or text mining which you have to deal with. Let us say that you are given a set of documents or as they call it, a corpus of documents. Now examples of such corpus of documents can be, say for example, if you want to do review mining, say suppose you want to do suppose like you basically, so let us come back to the sentiment analysis problem once again. So let us say that I am a retail owner. Let us say something like Amazon. I have a large number of products and I want to find out which for any given product, which are the things which that a particular user likes about it and which are the things that a user does not like about it. Okay, so in that case, so what is the from what source will I understand all these things? So one source is definitely the reviews written by the different users. So in this case, we can consider each review as a document. Okay. So each review will itself will not be a very large document. Like it may consist of about say like 100 words or something like that. And there will be a large number of documents. Let us say that for any product there are let's say about say 100 reviews. So total we have got a set of 100 times 100 equals, that is 10,000 like words like this. Now it needs to be understood that all these reviews like they are not like distinct. It's not that they contain distinct words. If a particular word appears in review 1, chances are that parts of it, some of those such words will appear in review 2 also. And this is especially true about the words which are of common interest, that is the words say for example, if it is a customer review of about a camera, let us say, then different aspects of the camera, they should be featuring in most of the reviews, because these are the when a person writes a review about the camera, they will probably write or make some remarks about the different parts of the camera, about its battery life, about its picture quality, about its cost, and and all those kinds of things. So there are certain words which will appear repeatedly in all the document, all these documents. Now since this is the data set with which we are going to work now. Now exactly what so what is the work in this case, that or what is the task? The task is uh, find which parts of the or which aspects of the camera are liked by the people and which aspects are not liked. So you can say something like aspect based sentiment mining. So now the first thing which we have to do is to construct the vocabulary of the vocabulary. Now, as I said earlier, now vocabulary is, or strictly speaking, vocabulary means the list of all the words in this language. But of course, that may be quite irrelevant for the purpose which we are dealing with. That is, we are dealing with this particular data set of about 100 reviews by customers on about a camera, and each of these reviews contain 100 words. So totally there cannot be more than 10,000 words in it. So that those words which do not appear in this data set are not of any relevance to me. So I do not really, for a particular task like this, we do not really need to consider the entire vocabulary. Rather, we will create our own vocabulary for this task. So how to build such a vocabulary? So the answer is very simple. You just consider all the documents one by one. Say this is my first document. Okay, so in the first document, let's say it contains a sentence like this. Of course, this is not a sentence which will appear in any customer review, but let us just say that this is a sentence. So what we will do? We will first scan all the words in the sentence one by one. So first of all, we see this word the. Now I can note down this word the as the first word of my vocabulary, and I can call it as V1. Okay, the first word which I have encountered. The next word, of course, is fox. So I just put it down as my V2. Third word is jumped. I put it down as V3. Next, similarly, this becomes V4. In case of the fifth word, the, I find that it is already there in my vocabulary. So V1. So I just do not call it V5, just I call it as V1 again. Again, similarly, I proceed like this, V5. So basically what we are doing, that is the like we have a set of documents like this. Every document is a collection of words. So now what I will do is I will no longer call these things as words. Instead, I will call these as word tokens. And these are the things these are the unique words, these which make up my vocabulary. These are what I will call as words. So in the convention of natural language processing, there is a difference between words and word tokens. Words, what is a word? A word is basically an element of the dictionary or the vocabulary. And what is a word token? A word token is like an unit of every document. A document is basically a sequence of word tokens. Now each word token can be mapped to a particular word in the vocabulary. So just like this one, this the word the can be mapped to the first word in the dictionary. So instead of calling it V1, I could have like I can just call it as 1. I can write this as 1, 2, 3. This I can write as 4. This again becomes 1. This becomes 5, and so on. So in this way, what I am doing is basically like all the documents, I am reducing to sequences of these word tokens like this, right? And each word token is mapped to a particular word in the vocabulary. So just remember that document is a sequence of tokens or word tokens. Each token maps to a word in the vocabulary. Okay, so this is the first component of a language, the vocabulary. Now, of course, we like as Professor Sudeshna Sarkar had mentioned in the last class. Now, these different words, some of these words can be considered as stop words. That is, they are words which which are like very common and usually are unlikely to carry any particular information for the kind of task which we are dealing with, right? So these so those words basically they can be removed. I mean it does not, it is not necessary to remove them, but because we want to do the computation, that is we want to be computationally efficient, so it may make sense for me to prune away the words that we are not going to use. So for that we can have a list of stop words. Okay, so what are the common stop words? So every language has its own set of stop words. If you consider English, some of the stop words can be articles. What are articles? Articles means things like the, an, etc. Then similarly, maybe pronouns. What are pronouns? Like say his, her, their, etc. Then maybe some prepositions, like say if, but, when, as, etc, etc. Like I guess you understand what kind of words can be considered as stop words. So now once we have constructed a vocabulary, I may, like if I want, it's not necessary, if I want I may remove the stop words from the vocabulary. So we can say that vocabulary is equal to initial vocabulary, or we can say refined vocabulary is equal to initial vocabulary minus stop words. Okay, and additionally another thing that needs to be done for the vocabulary is what is known as stemming. So for example, in my vocabulary here we can see jumped as a word which I have called as V3. Now later maybe I will come across say V15, which is equal to jumping. Now, so it is quite clear that jumped and jumping are like both originating from the same basic word, which is jump, and jumped and jumping are its different forms. So we can say that this so the next step after removing the stop words is stemming, which means removing the ed, ing, these kinds of suffixes, and just mapping them to unique words. So the first step is the stop word removal. Second step is stemming. So like after removal of software, I get a refined vocabulary. Then after that, we further refine vocabulary by stemming. And then similarly a few more things like some other kinds of preprocessing things we can do, and finally what we will get is the vocabulary which we are calling for. Okay, so this is like this is the first step. This is the step of the first step of natural language processing, which is building your vocabulary. Now we come to the next step. What's the next step? The next step in case of natural language processing, the next step is grammar. Okay. Now this so what is grammar? Grammar is basically a set of rules for constructing a sentence. Now, so we cannot just write take any set of words in a sequence and call it as a sentence, right? So we have a definite rules about which word can proceed, can follow which word, or in other words, what we have this concept called the part of speech, or the POS. So every word which we mentioned in the in the vocabulary, each of those words, I mean, whether you refine the vocabulary or not, each word can be assigned to one or more parts of speech. So we know what are the common parts of speech. We know that there are nouns, adjectives, adverbs, and verbs, right? These are the main parts of speech. Apart from that, also there are the articles, pronouns, prepositions, etc., etc. So the task of part of speech is, so once you have the vocabulary, the another important task is marking the parts of speech of each word. Now it also needs to be remembered that if there may be certain words which can be associated with different parts of speech. Okay, so there can be various words which are say both noun and verb, or which may be both noun and adjective, and so on, right? So whenever we are constructing the vocabulary, by that is, we may need to have this list of which word belongs to what part of speech. Now when we are now here we come across some kind of a trouble. That is, earlier I was telling you that for a given task, we do not really have to consider the entire data set, or the entire, I mean, the entire vocabulary of the language. It is enough to construct all the different consider all the words that are present in the corpus and build a vocabulary based on that. And but the problem, if we do such a thing, is that how will I know which word is what part of speech? Okay, so this brings us to the problem of part of speech tagging or pause tagging. So what is pause tagging? Pause tagging is basically, given a sentence, you have to find that is, you have to tag every word as it belongs to which part of speech. So that we can do only if we know which part of speech is supposed to follow which other part of speech like according to the rules of the grammar. Say if you consider the sentence that the example sentence we considered, it something like the fox jumped over the cat, or something like that. So for that, we have to somehow understand that this is an article, this is a noun, this is a verb, this is a preposition, again this is a an article, this is a noun, etc. So these kinds of things now, to understand which word is which part of speech, we basically need to know the rules of grammar. And the rules of grammar basically it's in a sense it is telling us which part, like to construct a sentence, which part of or what are like basically what sequences are valid. Say for example, like verb. Okay, suppose there is suppose I propose to you a sentence which has three word tokens and each of them is a verb. Obviously, it's not going to be an acceptable sentence. It's probably a grammatically incorrect sentence. So this VVV, this is not an acceptable sentence configuration. But the one which we have had here, what is it? ANVPAN, right? So in a sense, this is an acceptable sequence. So which sense is like which sequence of parts of speech is acceptable, which sequence is not acceptable? This is what is specified by the rules of the grammar. Okay. So basically, what does a grammar do? It gives us a set of rules for constructing the sentences in terms of its part of speech tags. So this is the grammar is the second part of the language. The third part of the language is semantics. Semantics as in the meanings of the different words. Now it may happen that like a particular sentence is grammatically correct. That is to say, like the the sequence of part of speech tags it has is acceptable according to the grammar, but the sentence may not have any particular meaning. So, so for that purpose, again, we need to consider that is the meanings of every different word. That is, every word will probably map to a real world object or a real world action or something in the real world, and that mapping is what assigns a meaning to a word. Now, there are also different words which mean the same thing. There are also some words which have related meaning. That is, there may be one word which means something bigger than the previous one. Say for example, consider the words vehicle and car. Okay. So we know that vehicle in this case is a general word and car is a specific word. And then you may consider another word like say jeep. So jeep, as we know, is a special kind of car. So it is an even more specific. So and then if you consider a particular model of jeep, let's just imagine J5. I mean, let's just call it as a fictitious jeep. So this is an even more specific. So first of all, there is vehicle, which is a general word. Next, it's a bit more specific, which is car. Then there is even more specific, which is jeep, and finally it is like as specific as then it comes as a model, which is like almost as specific as possible. Then similarly, under vehicles, you can also consider like other words, like say for example, sheep. Then from sheep, there may be more specific, like say steamer, and so on. So, so basically, the thing to note here is that each of these words, so these are all words in the vocabulary. Each of them belongs to a particular part of speech tag, and then there are these different words are related to each other according to some kind of relation. Now there may like so there may be synonyms, means two words which have the same meaning. Then there may be what they call as antonyms, means two words having opposite meaning. then similarly there are like other concepts such as I just said here. So this is basically some kind of a superset and subset relationship. So all these kinds of things have specific names. All these kinds of relations have specific names, which is which are used by linguists. So basically the third like now these various meanings of the different words and their relationships, these are all there is a repository of these different words and their meanings and their associations, and that repository is known as the WordNet. Okay, it's an online repository. So this WordNet is a very important tool for most of the NLP related problems. Okay. So I like so we will see this WordNet. So before that, just to recapitulate once again. So so if you consider any language, the most fundamental thing is the vocabulary, which is nothing but the set of words. The following the next important thing is the grammar. The next important component of the language is the grammar, which basically says or tells us what are the valid sequences of words. And then finally there comes the semantics, which means something like the meanings of the different words. Now like a sequence of words, they may, or a sequence of word tokens, they may all be part of a vocabulary, but they may not be grammatically correct. So to identify the grammar basically specifies which sequences are grammatically correct. Now again, just because a sequence of words is grammatically correct does not necessarily mean it has some semantics also. I mean, they have some meanings also. So the next component is to associate meanings and to also specify which kinds of which things or which sentences have meaning and which sentences do not have meaning. I mean, there may be sentences which are grammatically correct, but they do not have any meaning. Say, for example, I'm borrowing an example here. Say, okay, tasteless green ideas are shouting. This sentence, as you can understand, it is grammatically correct definitely, but it's semantically it is nonsense, right? It does not mean anything. There can for example, an idea can neither be tasteless nor can it be green, nor can an idea shout. So so that is to say, this word and this adjective tasteless or this adjective green, none of this can go in a sentence with this noun, which is idea. Like similarly, this verb shouting, this also cannot go with this noun idea. So which noun can go with which verb, which adjective can go with which noun? So all these things are taken care of by the rules of semantics. Okay. Now let us come to this concept of WordNet, which, as I told you, is it's an online tool which basically tells us the relationships between different words. So for any natural language processing tool or task which we use these days, this WordNet is a very important online resource, as it takes care of the all the three components: the vocabulary, the grammar, as well as the semantics. So let us take a look at what this WordNet is. So this is the this is the basically the website for WordNet. So that it was created by this Princeton University. So let us do something. So let us say, let us try to understand what this WordNet contains. Now let us take any particular word. So let us say cricket. Okay. So I search this word cricket. Let's say what WordNet has to tell us about this word. Okay. Just a second. Okay, let us first go here. Let us, okay, so this is the test to search. Yeah, let's see. Okay, so for here what it is saying that here first of all it is saying that the word cricket, it can be used as either a noun or as a verb. Now if it can be used as a noun, then it has two possible meanings, which has that is, so wordnet basically like as you can see, wordnet is a basically it's a collection of words, the vocabulary. Now it also specifies for every word it's part of speech. That is, about this word it is saying that it can be both as a noun or as a verb. Now so in some sense it is taking care of the grammar, because it's telling us about the part of speech of each word, and then it is also telling us about the semantics, that is the meanings of each of the different I mean there can be many words, as we said, which can have multiple meanings. So cricket is definitely one word which has multiple meanings. So one meaning, as we know, is a leaping insect which makes chirping sounds by rubbing the forewings. Another, of course, is the sport called cricket, which we all know. And then there is this the word cricket can also be used as a verb, although that may be quite unusual. But like we can sometimes we say that it's like cricketing. We sometimes use the word cricketing, which like can be used as a verb or even as an adjective, right? So like this is just an example of what we see in or what kind of things which we can see in WordNet. So we can search for other words also. And so if you like there can be other words which have, so this word, as you can see, it's both as a noun and a verb. Similarly, there can be words which are both a noun and adjective, etc., right? Say for or even within the same that is this word bass, for example. This can be both noun and as well as adjective. Now even as a noun it has many different meanings, like the lowest part of a musical instrument, the lowest part of a polyphonic music, a singer with the lowest voice, then something, then a kind of fish, etc., etc., right? So it so like this WordNet, it's a very important resource. Now what the WordNet basically does is it deals with not as individual words but as scene sets. Okay, what is a scene set? Scene set is as the name suggests, is basically a set of synonyms, meaning words which have the exactly the same meaning. Okay, so if you so based so like let us consider all the words in a particular language, or at least those words which are present in a corpus of a of a particular corpus which we are dealing with. So let us consider what WordNet does is that it considers the different words as nodes of a particular graph. Now those words which have the same meaning, they are clubbed together as a single node. Let us say now W1, W7 are synonyms. They have the same meaning. Similarly, let us say W2 and W43 have the same meanings. So I club them together as one node. So these are like each of these nodes are basically what WordNet calls as scene sets. Now, of course, not all words will have synonyms. So let us say that W3 is a loan word. I mean, there is no other word in its scene set. W4 is also loan. Let us say W5 and W18 and W69. These all of them have the same meaning. They are all synonyms. So they can be clubbed together, etc. Similarly, let's say we have W6 is alone, W7 alone, etc. Okay. Now what the WordNet does is that it builds a graph by connecting different of these word or scene sets by edges. Now, I'm sure you are all familiar with the concept of graphs. So graphs basically have vertices or nodes and edges. So whenever two nodes are connected by an edge, that usually means in most cases that those the quantities that are represented by those nodes, they are related in some sense. Now, a word net is a very complex kind of graph which has different kinds of edges. So let us look at this graphic here. So it's basically telling that the word net is a DAG, or by DAG what I mean is a directed acyclic graph. So what is a directed graph? Directed graph is such a graph where every edge has an arrow. Okay, it's pointing from one node to another. Now, why is the word net graph? Why is it directed? We will understand that. And what is the next thing? It's acyclic. This A stands for acyclic. That means what? The acyclic means that there are no cycles in the graph. That is, you will not see a structure like this. Okay, like so why is why should we not have cycles in case of this word net? Because the edges in the word net graphs, they basically incorporate the meanings of the different words. The meanings are somehow conveyed through these edges. Say for example, if you look at the small example that has been given here, say two words are there, carrot and radish. Okay, now each of these are so these are individual words, but you can consider them as synsets of size 1. That is, we do not know any particular synonym of carrot or radish, so we are just considering them as lone words. Now both of these are pointing to another word or another phrase, in this case plant root, right? So that means this direction of the arrow in this case indicates like is a kind of relation. That is, we can say carrot is a plant root, radish is a plant root. Okay, now from plant root there is another is a relation to another phrase, plant organ. So plant root is a plant organ, plant organ is a plant part, plant part is a natural object. But then again, there are many other things also which are natural objects. Say for example, as they have written in this case, sprinkler is a something. What is sprinkler? Sprinkler is a mechanical device. A mechanical device is a mechanism. Mechanism is a natural object, and etc. etc. So like this is the way in which different words or synsets are linked in the word net graph. And this arrow, this in the sense denotes a kind of relation, like is a like it's a specific to general direction. That is, the when A points to B, that basically means A is a B, or A is a specific case of B. A is specific, B is general. Now this, however, this is only so that is what is known as hypernyms. Okay. And similar, so hypernym basically it's so there is this concept of hyponym and hypernym. Hyponym means a more specific synset, and hypernym means a more general synset. Okay, so that is what is indicated here. Now, however, this is not the only graph which is associated with WordNet. There can be other kinds of relationships also between different words, which are constructed or which are represented by other graphs in this WordNet. Say for example, antonym relationships, opposite relationships. That is, like if two words are opposite to each other in meaning, they can have an edge between them. So like that is another kind of edges that are present in this WordNet graph. Okay, so like it's so basically WordNet is a complex graph which every node in the vertex, every node in the or vertex in the graph represent a synset, and every edge represents some kind of relationship between the synset, which may be as a hypernym hyponym relation, or an antonym relation, or some other kind of relation. Okay, so that is basically what this WordNet is about. And WordNet basically helps us to understand which pair of words have some kind of relationships. Now it often happens that two words do not have uh, any direct relationship, but semantically they are close to each other. So example, if you consider carrot and radish. Okay, now the word carrot and the word radish, it's like neither is one the subset of another, nor is one the opposite of other, nor are they synonyms, nothing like that. But like we can see that their distance in this WordNet graph is actually quite low, because both of them have a common ancestor in this common ancestor using this, or with respect to this kind is a relation. So we can say carrot is a plant root, radish is a plant root. So both of them are like, it's like they are having a common ancestor. So if you consider the graph distance, what's the graph distance? Graph distance is, you have a graph and you need to move from one node to another. So what is the number of edges that you have to traverse? So here, as you can see, the graph distance between these two words is only 2. So even though these two words are not like related to each other as far as say the like some of the basic relationships like synonym, antonym, hyponym, etc. are not true between these two. However, semantically they are quite close to each other, and so we can see lots of examples like this. Okay, so this, as I said, this WordNet, this is a very it's a very useful resource. Now, let us come on the basis of what we discussed. Let us come to various problems which we will come across in the with respect to this, like in the if we are trying to do some kind of economics using natural language processing or text mining. Say, so for example, suppose I want to understand that like from past news, I want to understand what are the kinds of events which impact the sales of my company. Okay, so first of all, I will consider the different news items. Okay, so first of all, what needs to be done is that I will first get what's my set of documents. My set of documents in this case is going to be just like news article 1. So let's say this is the news article 1. Next one is news article 2, etc. So I have a set of documents like this. Let us say I have n number of documents. Okay. Now, first of all, I need to focus on those documents which may be of use to me. So suppose suppose I run an oil company. My the product which which I sell is oil. So now all kinds of news are probably not going to be useful for me. Only certain categories of news will be useful for me. Like for example, sports news. It's unlikely that the result of yesterday's cricket match is going to have a bearing on my on the price of my oil, or say like other kind of news, say the domestic, suppose domestic affairs of some country, which does not have anything to do with the or that with my company. It's unlikely to have a bearing on my sales. So first of all, what I need to do is that out of all the news I have obtained from some news media, I first have to identify which pieces of news are important for me. Only those news items I will be focusing on. So what is for that, what do I need to do? I need to do document classification. So what is the document classification? Document classification is that you have these different documents. You assign every document to a particular category. So like for example, if we are dealing with news, then the obvious categories into which news can be grouped are as follows. Say for example, international, say for example, politics. Then maybe international relationships, international relations or affairs, international affairs. Then there can be the country's domestic affairs. Then there can be business and finance. Then there can be science and technology. Then there will be sports. Then there can be say lifestyle. And other categories may also be there. So basically my first and foremost task is I have a huge corpora of documents. Out of that I need to find out which documents are useful for me. So for that I need to solve this document classification problem. So now how do I do document classification? So for that, let us come to this concept. So let us take any particular document. So let us say W1, W2, etc. This is a sequence of the word tokens which are present in the document. Let us call it as D1. And now what I need to do is like basically this document classification problem, I have to pose it as a machine learning problem and learn to solve it. So what is to be done? In case of normally in case of machine learning, what happens is that I have a training set which is labeled, and then I have a test set. This and test set is unlabeled. The labels have to be predicted. So now what has happened is that I have been provided with a training set which is labeled. That is, I know the in every document. So what does the training set contain? Training set contains a document and its label. Okay. So this is the document and D, and the label Y is and the Y is the label. So if you consider this particular case, so it's like every document is it's a news article, and it is accompanied by a label, meaning what kind of a news is it? Is it politics news, or is it sports news, or is it finance news, or what is that is included in the labels? Okay, so now this basically allows me to now what is this document? Document again is a collection of, or rather a sequence of word tokens. Okay, so now what do I need to do? So what is my task now? The task is basically given a new document, you have to like predict its label. So what the simplest way to do with this task is as follows. We basically learn something like a probability distribution. We that is under a particular topic, which word is likely to occur. Let us say suppose the label is say sports. Okay, now the question is, consider any particular word W1. So how likely is the word W1, how likely is this word to appear in a sports document? Say for example, this W1 is say for example what to say, maybe mango. Now in a document which is labeled as sports, as we can understand, the word it's highly unlikely that the word mango will be present in it. So this will have very low probability, maybe something like 10 to the power minus 3. But if on the other hand, if you consider the word say ball present in a sports document, we know that its probability is quite high. Let's say it's something like 0.1. Now 0.1 may seem to be a low probability, but actually it is not. So it's like basically all the words which are there in your vocabulary, you are that is calculating the probability, how likely they are to appear in a document which is marked as sports. Okay, so there can be your vocabulary can be quite large. Let's say that even after a stop word removal and all stemming and all those things, you will have a vocabulary of 5,000, right? So the entire probability mass of 1 is to be divided among all these 5,000 words. So now, so that way, if it is uniformly distributed, every word will have this much probability, 1 by 5,000. Now compared to that, this word ball, it has a probability of 0.1, right? So which is quite significantly high rather than 1 by 5,000. So we can say that compared to any random word, this word ball is actually quite likely to appear in the topic called sports. Okay. So similarly, so how do I measure these probabilities? The answer is these probabilities are nothing but relative frequencies. So what do I mean by relative frequency? What I mean by relative frequency is that you simply take up any of the labels. So in this case, these are the different possible labels. You consider all the documents which have this particular label. Okay, let us say document in this case, let's say document D1, document D7, document D17 and document D23. These 4 documents have the label of sports. Okay, now what you do is you look at all the word tokens which are present in these documents, and you basically calculate the frequency of them. And you normalize them. So let us say that so let us consider how many or how frequently has every word in your vocabulary appeared in these 4 documents. Okay, so as we had said earlier, let us say that there are 5,000 words in my vocabulary, which I am denoting by, let's say, V1, V2 up to V5,000. Okay, so what I am going to do is so this is basically a word and this is its frequency. So I will count how many times the word V1 has appeared in these 4 documents. So F1. How many times V2 has appeared in these 4 documents? F2 and so on. So now let us say that these 4 documents together have capital M number of words. So then I will say that the probability of the word V1 under this label sports is equal to F1 by M. Why F1? Because that is the number of times the word V1 appeared in these 4 documents. Okay, and why M? Now, because M is the total number of words or tokens present in these 4 documents. So F1 by M, this is like the probability of the word V1 in the under the topic sports. Okay, similarly, like if you consider V2, it will have some probability. If you consider V3, it will have some probability, and so on and so forth. So that way, all the words in the vocabulary will have certain probabilities under under each of these topics. Okay. Now, each of these topics or each of these labels themselves will have their own probabilities. So which we can denote by P of Y. What is P of Y? So P of Y is basically, it's like nothing but the relative frequency of the label itself. Okay. So let us say that I have total n number of news reports here, as I have already said. Okay, out of which I have said that these 4 are related to sports, right? So out of so I can say that probability y is equal to sports is nothing but the relative frequency of labels marked as documents labeled as sports out of all the documents. So in this case that is nothing but 4 by n. Okay. So now I have so now using these two quantities, that is quantities of this type, p of y and p of w given y. Okay, p of w given y and p of y, or instead of w, let's say p of v given y and p of y. So using these two kinds of quantities, I will be able to solve the problem, that is given any tests or any test document, what is its label likely to be. How? So to understand that, we have to take the help of Bayes theorem, or as they say, we have to do Bayesian analysis. So what is the Bayes theorem? You are all familiar with. Bayes theorem basically says you have two random variables a and b. So Bayes theorem says p of a times p of b given a is equal to p of a given b times p of b. This is a Bayes theorem. Now in this case, what do you have to do? You are given a document, okay, a document D, and you have to predict its label Y. Okay, so what you really need is what is a distribution like this: probability Y equal to something given D, right? So what is given that this is my document, what is the probability that this is related to science and technology? For given this document, what is the probability that this is equal to sports, right? Now here we apply Bayes theorem. How do I apply Bayes theorem? I apply is equal to P of D given Y equal to ST times probability of Y equal to ST divided by P of D. Okay. Similarly, what is this one? This is equal to P of D given Y equal to sports times probability Y equal to sports divided by probability of D. Okay. Now what is D? D, as I said, is a sequence of word tokens like this: W1, W2 up to, let us say, WM. Okay. So a document is, as a once again, document is a sequence of tokens. Now what am I going to do? I am now going to, so in this the simplest thing I can do is just to assume that the sequence, the tokens are independent of each other. So P of D given Y equal to sports, this I can just write as the product of P of W1 given Y equal to sports times P of second word given Y equal to sports, etc, etc. I can just go on multiplying. So this is basically is equal to product I equal to 1 through M. M is the number of tokens. P of Wi given Y equal to sports. Right? Now now this I have already estimated. Right? Because this word token Wi, this word token Wi is can be mapped to a particular word in the vocabulary, and I have already calculated the probability of that word under this given level. So I can say that this thing has already been estimated. From where? From the training set. So by multiplying all these probabilities, I can get this quantity, and this thing, the probability of a given level, this also has already been estimated. right? The relative frequency of this particular level. I had 100 news items, out of which 12 were about science and technology. So 12 by 100 is my this particular probability. Okay, so similarly, these also like I can get these also. Now this P of D, this might be harder to calculate, but I don't really need it, because I know that these things any document I know that it will have one of these levels. So it has, let us say it has k possible levels. So this one I call, let's say this one I call as P1. This one I call as P2, and so on. So similarly, like I can up to all this way, I can get up to Pk. Okay, so note that in all of these cases, they have this constant factor of 1 by Pd. Now 1 by Pd, how much it is, I have not estimated. The rest of it I have estimated. So basically this P1 is some value by Pd. P2 is some value by Pd. So Pk is some value by Pd, and so on. Now I know that since this document D must belong to one of these k labels, so I am sure that P1 plus P2 up to Pk, this defines a probability distribution. So the sum of these probabilities is equal to 1. Okay. Why? Because like it's because that since the document must belong to, it should be either science, technology, or sports, or politics, or business, finance, or something. That is, every document has to belong to one of these categories. There is no other option. So the probability of those things has to be equal to 1. Okay, so I know that so from using this I can estimate PD. Okay, this helps me to estimate PD, and once I get PD, I can get the numerical values of these probabilities. So now for a given document, I will get these probability values like P1 is equal to 0.03. That is, the probability that this document is related to science and technology is only 0.03. P2 means the probability that it is related to sports is 0.35. Similarly, P3 means the probability that this document is related to, say, related to politics is 0.12. P4 is the probability that this is related to, say, business and finances, and its probability is 0.23, and so on. So this way we can, what we'll get is a probability distribution over the levels, and whichever is the most likely, in this case this one, I can declare that as its its most likely level. So I see that the given this document, it seems it's most likely to be a sports document. So I can classify it as a sports document. So now if you consider the news the news articles which we considered, this way what we will do is that we will first categorize all the news articles, and I will simply throw away those news articles which are not related to anything of my interest. So if I am trying to predict the prices of my oil company based on news, I am surely not going to look at sports. I am most likely not going to look at or very unlikely that I am going to look at science and technology. So I'm certainly not going to look at, say, something like lifestyle. I will probably be looking at the business and finances. I may be looking at international affairs. There is also some chance that I will be looking at political news in my country, and so on, right? So given that kind of a corpus, your first task is to focus only on the documents that are relevant to you. So that is achieved with the help of this kind of text or document categorization, which is achieved in using this way. Okay, so we will continue this discussion on Thursday, and I would also like to remind you that, as I say, I sent out a mail that on Wednesday 4 to 6 p.m. there is going to be a special session organized by MathWorks India, in which they will give hands-on demonstration of the various concepts that you have learned in this course. so please attend it. Okay, so it will be helpful for you. Okay, so please so I have provided a link where you can register for that. That it's basically it's a webinar, so please register for that webinar. So we'll be there, and so yeah, so please attend it, and so that you get the maximum amount of this course. Okay, so hope to see you on Wednesday during that webinar, and our next class is on Thursday. And also to also this is to declare that next Monday, which is the 15th of November, we will have our last exam, which is like which is basically on the on whatever will be covered till then. I mean between the third module and basically whatever can be covered it as the fourth module will be part of the syllabus on next Monday's test. It will be a very short test, and yeah, and the deadline of the phase 3 of your first assignment, that will be towards the end of next week, so I will send out a mail regarding that also. Okay, thank you.